Okay, hello and welcome to this lecture on the problem solving sessions for ML. We will be discussing a few practice questions for each of the topics we have studied all this while. Okay, this will help you to strengthen your concepts that you have learned. As always, a brief about me. My name is Aditya Agrawal, and I am a recent graduate, postgraduate in computer science and engineering from the Indian Institute of Technology, Madras. I worked in Hyridis Technologies as a data scientist, and that's where I got introduced into the world of ML. And today we will be solving some few questions. I will start with the first question. And these questions are based on two topics today, which are the first two topics we learned. One will be the introduction to data science, machine learning, and the second part will be on the k nearest neighbors algorithm. So let's begin. This is the first question. The first question says that how would you handle missing or corrupted data in a dataset? So there are a few options given, like you would drop the missing rows or columns, you would replace the missing values with the mean, median, or mode, you will assign a unique category to the missing values, or you will do all of the above. Okay. So what are the ways by which you can handle missing or corrupted data in a dataset? So the correct answer to this question is option D. You can do any of the above, but there are some scenarios where one will not favor over the other. For example, look at option A. So option A says you will drop those missing rows and columns. For example, let's take a, so the option A says you will drop the missing row or column. Okay. Now, the thing is, if you have a very large data set, right? Large data set in the sense, so if you have a large data set, let's say there are 1 million rows, okay? And it consists of two classes, and it consists of two classes. So y belongs to either 0 or 1, so positive or a negative class. And the data is balanced, okay? So it's 50-50, okay? 50% are 0, 50% are class 1, okay? There's no imbalanced data set. It's a perfectly balanced data set of 1 million rows. Let's say you did some analysis of the data and you see, and let's say there is only two features, F1 and F2. Okay? There are two features, okay? And upon your data analysis, you found that F2 has no missing value, which means for each row in my data set, F2 is populated. For each row, there is a value present for F2. But for F1, there is missing values. Okay. And you dig deep a bit more and you found that there are 50 rows with missing values. Okay. Now, on a data set with 1M rows, right, there is no problem if I delete 50 rows. Okay. Rather than me making a guess on some row, on some value, what I will do is I will just remove those 50 rows. I'll just drop those 50 rows. Now, it could also, you might think that what I will do here is, let us say that F1 is a feature which has about 100k rows with missing value. And you might think that this feature has not much value in it because there are significant number of rows with missing values. For example, in this case, 10% of the rows. You might think that I can drop the F1 feature column. Now, if you understand, right, you had only two features and you are now planning to remove one of the feature only because 100K rows do not have a value in them. The other 900K do have. So in this scenario, since you have a less feature set, then dropping the feature F1 might cause some issue. Again, why might, I will explain. It might cause some issue. And that is why it's not always advisable to remove features or remove columns. Remove columns is same as removing features if you have a data set with less number of feature set. So, and another example of how you would remove columns or features would be even after you having um, even after you having a very good um, feature with all the values populated, you might still drop it. So what do I mean by it? Let's take a simple example. So all of you have heard about, I guess, the house pricing data set, right? Everyone has heard of it. So there are two features. So one is the number of bedrooms, hall, kitchen. That's a 2 BHK flat or a 3 BHK flat. And there's something called square feet. Okay. And this is my Y, which is the price. Okay. The price of the house. Let's say I'm just populating with some data 2, 1, 1, 3, 4, 2. Okay. Number of square feet for this will be, let's say, 1000. This will be 1100, let's say. This will be 900. This will be, let's say, 1400. This will be 1800, let's say. And this one is again 1100. Okay. The square feet, number of square feet of the house. Okay. Now let's say for this one it is 1 CR. Let's say for this one it is 70 lakhs. Okay. Or maybe let's say for this one, since it's a bigger house, okay. I mean, square foot wise, it's bigger, even though it has one bedroom, that's okay. It is, let's say, 1.1 CR. This is, let's say, 90 lakhs. And let's say this is 1.4 CR. Let's say this is 1.8 CR, and this is 1.1 CR as well. Now, if you see very carefully, right, there's a reason why I have written the data set like this. There is a direct relation between square feet and Y. Okay, you mean see 1000 square feet, 1 CR, 1100 square feet, 1.1 CR, 900 square feet, 90 lakhs, 1400 square feet, 1.4 CR. So by looking at this data only, you will be able to build your linear regression model, right? It won't be very, very difficult, correct? It will be Y equal to some, let's say this is X1, this is X2. So some bias term plus some value times X2 plus some value times X1. And then you can find out. So now you can see that X2 has a very good indicator, right? By just using X2, I'm able to estimate the value of my price very easily. And in this scenario, when X1 is not that relating to the my target variable, which is Y, in that case, even if you remove, let's say X1, it won't do any too much harm. Okay, by looking at this data set. So that is how also you can remove this data missing column. And this thing is also called correlation analysis. So you are trying to find the correlation between each individual feature with the target variable, and whichever has the highest amount of correlation, you will keep it, and the one which has very less, you will remove it. Okay, so this was the option A. Hope you understood this. So option A is not very favorable if you have a lesser number of rows or if you have a lesser number of columns. Option B says you will replace the missing values with mean, median, and mode. So mean, median, or mode, as you know, are three types of central tendency where you can, given a set of data values, you might find out that which column has what is the average value of a column, what is the median, or what is the mode. Again, I've explained in my lectures as well. If a data set has outliers, then maybe using the mean is not the best measurement, because mean is very susceptible or very affected by outliers. In that case, you will use a median. And mode, again, if there are multiple values, if there's a column with only unique values, then maybe mode is also not the best measurement in this scenario. But median actually works for almost all the scenarios, and median is what I would prefer to use always in my projects as well. Option C is assign a unique category to missing values. Again, you can do this. You can maybe, if you don't want the model to suffer, if you don't want a model to say, oh, this is blank, right? You can just assign a unique category that if this value is missing, then that means it belongs to some other missing category, let's say. Okay. That way you can assign it a category, then you can do one hot encoding, label encoding. I've not talked about all this, but again, so it's more like you'll assign a different category to this variable and analyze that category on its own. Okay. So that would be the three options, and typically one would employ any of these three options. That's why the correct answer is option D. So moving on to the next question. When performing regression or classification, which of the following is the correct way to pre-process the data? So before you always do regression or classification, you would do something called data gathering, which is if you have a relational database, you will fire up an SQL query, get in the corresponding data, put it in pandas, or maybe you can directly download it from a source, the CSV file given in an S3 bucket, let's say. There are many ways you can get the data from, right? There are different data sources. You can get the data, then you pre-process the data. So during pre-process, you can do something called normalization of data. You can do something called principal component analysis. So if, again, if you remember, PCA, we typically employ doing when we want to, reduce the dimensionality of our data. So if you have a huge dimensional data set and you want to reduce it to some small number of dimensions, then you would do PCA. And one thing about PCA is you're trying to project data onto a line, right? You're trying to find the principal components and you're trying to project the data onto a line. And that is why it's always advised, if you are in this scenario, if you're trying to project, if you're trying to find, so if you're trying to use the variance. So if you remember, PCA uses some method by it tries to maximize the variance of your data set. For example, if you have something like this, let's give a very small example of a data set. Okay, let's say you have a, okay, maybe I'll try again. Yeah, so maybe there is a data set like this, and you might think that, so Aditya, what I can do is, maybe I'll do something like this. So I will take this as my principal component, the x-axis, right? And project all my points on this axis. Okay, and that way, that will be one of the ways I can reduce the dimension from a two-dimensional set to a single-dimensional data, right? But if you think of this way, you can see that many of the points will overlap in this scenario, and you won't be able to get to know about the spread of the data, which is the variance. So what PCA tries to do is PCA tries to preserve the variance of the data, so that will give some insight into the prediction part. So that is why what we do is we typically find principal components, which are lines, where I can project the individual points onto this line, and that will be my principal component analysis. So whenever we are dealing with variance of a data set, and anytime when we're also dealing with distance formula or anything as such, okay, then it is always advised to normalize the data first, then do PCA, and then after that you do the training. Okay, so you normalize the data, do PCA, and then you do the training, and that is why the option C is your option A, sorry, is your correct answer. There is no point of normalizing the PC output. Once you get the value of the PCA, or once you get the principal components, they will also be normalized by default. Okay. Cool. So the next question is, what is the difference between a validation set and a test set? So if you have saw my lectures, I have given a very good example in that scenario about what is the difference between a validation set and a test set. So I hope this won't be very difficult to answer. The correct answer to this question is option A, right? So option A will be the validation set is used to evaluate the per. Okay, wait a second. Sorry. So option B will be the right answer in this case. Why? Because I'll explain why each option is incorrect. Option B is a validation set is used to evaluate the performance of a model during training, while a test set is used to evaluate its performance after the training. Correct. And so typically, what do you mean? What do I mean by this is, so it's more like, so if you are preparing for the GATE exam, right? Let's say you are preparing for the GATE exam, and your training set consists of these lectures, okay? Which means you're trying to build a model, you're trying to learn something, learn the concepts of the GATE exam. So your training set will be some lecture videos, okay? And your testing set is the GATE exam, okay? And when you actually give the GATE exam, you only use the model, which is you have watched the lecture videos and you have learned the concept, and then you apply it in the GATE exam. Okay, there is no point of improving that time. Okay, whatever you have done, you have done. The GATE exam is a D day. We call it the D day, right? D day means it's the day where you have to perform. So how can you guarantee that the lecture videos that you are watching is actually helping you to crack the exam, right? And that is where the concept of a validation set comes in. What the validation set will do is, what you would do in the scenario is, you will solve some practice questions, or you will solve some previous year question, right? PYQs or previous year questions that will help you to understand that whatever lecture videos that I'm watching, that I'm learning, whether that will help me to perform good in the GATE exam or not, right? So a validation set is used to evaluate the performance of the model during the training process, while a test set is used to evaluate its performance after you have trained the model. Once you are in the testing set, you are not supposed to modify or refine your model. It should not be that you are giving the GATE exam, you see that, oh, I will look at this answer of this question, you see the option is A, and then you will go and refine. You can't do that in the exam, right? But what you can do is you can solve the previous year questions, get a hold of what is the correct answer, improve your model based on the feedback you get from the solving the question. So that is why a validation set is used. Again, option A is incorrect here, because validation set is not just used to tune the hyperparameters. There are models, there are some models which do not have any hyperparameters. You can still use a validation set. For example, validation set is used when you are trying to train a model with number of iterations n. Your testing error usually goes, training error goes like this, which it always reduces the training error, while your validation error will first decrease and then increase. At this point, you know that you are, after this point, you are overfitting the model, so you would stop your model training at this point, right? So that is the best way you can say that. And validation set and test set are the same thing. Again, no, they are not the same thing. You can use a validation set to fine tune your model, but not a test set. A validation set is not necessary. That is also somewhat correct. Okay. I mean, this is now it is so much required validation set. It's more like, if I tell you, let's say you are watching only the lecture videos, can't you crack the GATE exam? Can't you get rank one? Maybe you can get, maybe you can get, okay? Maybe you are thinking that, oh, okay, I will train and train and train. My training error goes here. Lord forbid the test error, validation error, I don't care about it. And then you are believing that in the test time, during the exam time, GATE exam time, I will crack the exam, right? That is also not the right approach to these questions. So validation set is also necessary to in machine learning, but it's not mandatory. It's not that you need to do it. Okay, fine. Okay, so the next question that we have here is, um, choosing, this we come on to k nearest neighbors, and the question is, choosing dash values for k can be noisy and will have a higher influence on the result. Option A is, do you select a smaller k value? B is, do you select a standard k value? C is, do you see a large k value? Or D is all of the above. Which values of k that you can choose that will make your model a bit more noisy and have a higher influence on the result. Okay. I hope you guys are pausing the video and thinking some time and then looking at the solution, because then only you will learn. Just try to apply your concept and then you will be able to answer it better. So correct answer to this question is smaller. Why is smaller? Okay. It's a very, very basic thing. Okay. And why? So first of all, let's say if you haven't sample data set, okay, and let's say it consists of two classes, crosses and circles. Okay. And these are my green circles. Okay. Just a basic data set. Okay. Let's say my value of k is 1. Value of k is 1, meaning I will only look at the nearest neighbor, the first nearest neighbor to the data point. Let's say the data point is this. Maybe I'll just make it such that you guys understand the point. Let's say it's this. Okay, and I ask you how would KNN classify this point? Will it be green or red? Your model, if it looks at the nearest point, it looks at this green point and say it's green. But if you look at the data, does it look green? Because if you see this data, if I would have taken more number of predictions, let's say I would have taken the 4 nearest neighbors, then maybe I would have easily answered red, because 3 of them are very close. Only one is the green part. Maybe that green data is noise. For some reason, it falls on this part of the falls on the red area, right? So that is why that's called noisy. Okay. Now let's say I will increase the value of k to 3. You would see this one, and this one, and the point could be classified now as red. So the smaller the value of k, more will be on noisy. Okay, and will have a higher influence on your result. Okay, there's nothing called standard k value, by the way. In KNN depends on your data set. Okay, so that should not be confused by that word in itself. Okay. Okay. So this will be the last question for this video. I plan to cover 5 questions in each video. Okay, forgot to mention that. Sorry about that. So this is the last question of this video, and this will help you to learn a new concept as well. Very important. Okay, not from a gate perspective. You can think of it if you are looking for a job in the ML field as well. So feature scaling is helpful in KNN algorithm. Do you think true or false? Right? The answer to this question is true. Why so? So before that, if I ask you a very basic question, okay? Let's say very basic, okay? Let's say you have a test data point, X test. The data set has two features. One is the number of bedrooms it has. Again, we go back to the same example we showed a bit earlier. Let's say it is 1, comma, the square feet of it, let's say it's 1100. Okay, this is my X test. And let's say you're trying to find out the distance from a point, let's say XP, which is given as 1, 900. Okay. Now, if you calculate the distance of the point XP and X test,
You are currently the only person in this conference.
yeah, I think for some reason I got disconnected. I don't know how. But X test and XP, there are 2 points. And let's say the distance you will calculate, you will say it's 1 minus, let's say you're using Euclidean distance plus 900 minus 1100 whole square, right? Now, if you calculate the distance, you will always see that this term will be huge compared to the first term, right? The second feature x2 will be huge as compared to the first feature x1, correct? So always whatever distance you find, x1 will have very less impact on it, because you are always considering, because the range of values for x1 is much lesser than the range of values for x2. So that is why what you can do is you can do something called feature scaling, which is you're trying to change the range of the individual features. Again, how does it work? There are two ways to do feature scaling. One is called normalization. In other words, it is also called as min-max scaling. Okay, so normalization would mean that if you have a feature x, the value of the feature x will be x prime, let's call it, is whatever is the original value x minus whatever is the minimum value of the feature, which is x min, divided by what is the maximum value minus what is the minimum value. And I can guarantee that x prime will always lie between 0 and 1. Again, how so? Let's say if the value of x is x min, okay? I see x, the minimum value of x, I'm calling it as x min. Then the value of x prime will be 0. If you plug the value of x equal to x min. And if the value of x is x max, then numerator and denominator become the same. And that's why x prime will be 1. This way, what you are doing is now each of your values of your data set are lying in a range from 0 to 1 rather than it being like the difference being huge. And the other method is called standardization. Standardization ensures that whatever transformation you do to the dataset, whatever you do the feature scaling, okay. So what I'm saying is x prime is x minus mu over sigma, where your mu is the mean and sigma is your standard deviation of your dataset. Standardization, what it does is it doesn't ensure that the individual values are have the value between 0 and 1. It ensures that the final mean of the data set will be 0 and the standard deviation will be 1. Again, which is better, which is not, that's not the point, depends on the data set. But these are the two ways you can do it. Some people also call normalization as min-max scaling. Okay, it comes from the formula itself, but don't be confused with that. Normalization means the same thing as the min-max scaling. Okay, so feature scaling, if you can do here in this KNN algorithm, if you can convert the features, you can do normalization. What typically people do is they do normalization. They use some method to find the optimal value of K, and then the optimal value of K they use and train the model, they get some score. Then they do standardization, do the same thing, and then they try to find that whichever score is better, that will be the final conclusion to this data set. Okay, so this is all I wanted to talk about in this lecture. I hope your concepts are a bit more strengthened after looking at this lecture. In the next lecture, we will talk about the next two topics that we taught here, which is, I guess, naive Bayes and logistic regression, if I recall correctly. And after that, we'll also look at the other two topics and two topics and two topics. These are small, short, half-an-hour videos for you to better grasp the concepts of machine learning. Okay, and if I can give you okay, so what I will do in this case is I will also give you a few tips as well. So make sure if I ask you a question, like I think I covered it in the class as well, that in KNN, should the value of K be odd? What is the advantage of it being odd? Does it make any sense if I make it even? See, it will work absolutely okay if it is even, but in the even scenario, it could be that let's say that by binary classification problem, if it is select the value of K as 4, let's say, then 2 points might belong to one class and the other 2 belongs to the other class, and that can cause an issue in which there can be a tie. So to break ties, we typically use an odd number, right? So there could be other questions like convergence. You can see the convergence proof that I've showed in the class. Lectures are uploaded on YouTube for you, and that would be very, very helpful for you to understand more about these concepts. Again, other lectures will be coming after this lecture in the near future. If this is helping you guys to learn more and solidify your concepts and boost your confidence, then make sure you subscribe to this channel and like and share this video with your friends, with your peers who are trying to also prepare for the exam. And we'll see you in the next lecture. Thank you for joining. Goodbye.